Step outside, look around. Solid ground, breathable air, a sky that doesn't try to tear you apart. You live on a planet so stable, you've never had to wonder why. It shouldn't be. The moon above you is a cosmic accident. The ground beneath you should have stopped moving billions of years ago. Every breath you take should have been stripped away by solar wind. We've studied over 5,800 exoplanets across our galaxy. None of them look like this. None of them behave like this. Statistically, Earth is impossible. What if you're not living on a normal planet? What if everything you call normal is the result of accidents so absurd they should never have happened? What if Earth was never supposed to exist? Today, we walk through every collision, every coincidence that built the world under your feet. From the moon above to the iron in its core, and by the end, you'll understand why some scientists believe none of this should be here, including you. Ready? It starts with something you've seen every night of your life: the moon. You probably think it's always been there, a peaceful, ancient companion in the sky. But our moon is the largest moon, relative to its planet, in the entire solar system. We carry a sphere a quarter our own size, locked in our orbit. That ratio shouldn't exist. Mercury has no moon. Venus has no moon. Mars has 2. Tiny, deformed potatoes, barely 1% the size of ours. So how did we get a fully formed world following us through space? The answer is something scientists call the giant impact hypothesis. Around 4.5 billion years ago, a planet called Theia, roughly the size of Mars, slammed into the young Earth at over 14,000 miles per hour. The collision should have shattered both worlds. Instead, it sheared off a piece of Earth's mantle, threw it into orbit, and that molten debris cooled into the moon you see tonight. That's already absurd. But here's the part nobody tells you. Without the moon, your planet would wobble. Earth spins on a tilted axis, 23.5 degrees. That tilt is why we have seasons, why crops grow on schedule, why civilization could ever stand still long enough to build cities. The moon's gravity locks that tilt in place. Without it, Earth would tip and rotate chaotically over millions of years, sometimes pointing its pole at the sun, sometimes lying on its side. Mars lost its big moon billions of years ago. Mars's axis now drifts between 13 and 60 degrees. Mars is what Earth looks like without us. We are here because something the size of Mars hit Earth at the exact right angle, at the exact right speed. A few degrees off, Earth shatters. A few miles per hour off, the debris falls back. The moon happened by accident. We have never observed this kind of accident anywhere else in the galaxy, which means something strange. Earth may not be normal. Earth may be the exception. And exceptions in the universe rarely last. But the moon is only the first impossibility. The second is hiding directly beneath your feet. Look down. The ground feels solid. It isn't. The planet beneath your feet is actively trying to recycle itself. Entire continents are temporary. Even mountains have expiration dates. Your home is a stage, and the stage is moving. What you're standing on is a thin sheet of rock, about 35 kilometers thick, floating on top of a churning sea of liquid stone. This is the crust, and it's broken into pieces called tectonic plates that drift, collide, and recycle the surface of the planet over hundreds of millions of years. Almost every other rocky planet we've ever studied stopped doing this billions of years ago. Venus is the same size as Earth, same material, same distance from the same sun. Venus is geologically silent. Its crust is a single, fused shell. It doesn't move, it doesn't recycle, it doesn't breathe. That single difference is everything. Plate tectonics on Earth isn't just geology, it's a planetary thermostat. When continents move, they bury carbon dioxide deep underground. When volcanoes erupt, they release it back. Over millions of years, this cycle has kept Earth's temperature in the narrow window where liquid water can exist. Without it, the carbon dioxide our biosphere produces would accumulate. The atmosphere would thicken. Temperatures would climb to over 460 degrees Celsius. We would become Venus. So why does our planet have moving plates when no other terrestrial world we know does? Because of water. Earth's oceans seep into the crust, weakening the rock at the boundaries between plates. That's what lets them slide. No water, no slide. No slide, no tectonics. No tectonics, no atmosphere worth breathing. Venus has no water. Mars lost its water. Earth somehow held on to its water. But Earth shouldn't have water either. We'll come back to that. Because right now, there's a question scientists almost never ask out loud. Why did Earth survive when Mars didn't? The answer is hiding 3,000 kilometers beneath your feet. And it's the third coincidence. You can't feel it. You can't see it. But it's the only reason your atmosphere is still here. 3,000 kilometers down, the center of the Earth is on fire. Our planet's core is split in two. An inner core of solid iron, hotter than the surface of the sun. And surrounding it, an outer core of molten iron and nickel, swirling and convecting under unimaginable pressure. As that liquid metal moves, it generates electric currents. Those currents generate a magnetic field. That magnetic field wraps the entire planet like an invisible shield. That shield is what stops the sun from stripping this planet bare. The sun is constantly throwing charged particles at us, what we call solar wind. Without something to deflect it, this radiation would peel your atmosphere away, molecule by molecule, until there was nothing left to breathe. We know this because we watched it happen. Mars used to have a magnetic field. Mars used to have rivers, lakes, an atmosphere thick enough to hold heat. Then Mars's core cooled down. The dynamo stopped, the shield collapsed, and the solar wind tore its sky apart over 1 billion years. Mars went silent. Venus suffocated under its own atmosphere. Earth survived. But none of us know exactly why. Earth is small enough that its core should have cooled by now. We should be Mars. But our core is still molten, still spinning, still generating that field. For reasons scientists don't fully understand. It might be heat from radioactive decay. It might be the moon, stirring our insides through tidal forces. It might be sheer chance. Whatever it is, this is what stands between us and the surface of Mars. So let's pause, because what we've already found is staggering. So far, we've found 3 impossibilities: a moon that shouldn't exist, a crust that shouldn't move, a core that shouldn't still be burning. Any one of these alone is unlikely. All 3 on the same planet? Statistically, it shouldn't happen anywhere. And we're not done. There are still 3 more accidents that built the world under your feet. The water you drink, the giant planet that's been protecting us for 4 billion years, and the star that allowed any of this to exist at all. Stay with us. Earth is the only world we know of with liquid water on its surface. Liquid water is the universal solvent, the medium where every chemical reaction of life takes place. No water, no life, not as we understand it. So where did Earth's water come from? Here's the strange part. Earth shouldn't have any. 4.5 billion years ago, when the sun was young and violent, the inner solar system was too hot for ice. Any water near where Earth was forming would have boiled off into space. The early Earth was a ball of dry, molten rock. Our oceans came from somewhere else. During a period scientists call the Late Heavy Bombardment, the inner solar system was pelted by an extraordinary volume of comets and asteroids. Some of them, frozen visitors from the outer solar system, were made of ice. They crashed into Earth over hundreds of millions of years. Other water arrived, locked inside the minerals of asteroids from the asteroid belt. The early Earth was bombarded, relentlessly, by the most violent rain in the history of the solar system. Some of that water boiled off again, but just enough stayed. We didn't earn our oceans. Entire oceans arrived from space. By accident. Every drop you've ever swallowed was carried here by something falling out of the sky billions of years before there was a sky. And the deliveries are still happening today. Every small meteor that survives the atmosphere brings a few more molecules with it. Your morning glass of water is older than the planet you're standing on. But that bombardment that delivered our oceans should have never stopped. The asteroids that brought us water should have kept coming. Over 4 billion years, they would have flattened every civilization that ever tried to rise on this planet. Something stopped them. Something the size of a star. We zoom out, way out, past Mars, past the asteroid belt, to the largest planet in our solar system, Jupiter. Jupiter is more massive than every other planet in our system combined, twice over. It's a failed star, almost dense enough to ignite, but not quite. And for most of human history, we thought it was simply a beautiful gas giant out there in the dark. It's much more than that. Jupiter is the reason you're here to read this. Asteroids and comets, the kind that delivered our water, are still moving through our solar system. Some of them, given enough time, would have eventually hit Earth. Not a few. Many. Constant bombardment. Mass extinctions every few million years instead of every 100 million. Jupiter stops them. Jupiter may have saved Earth billions of times. Its immense gravity sweeps the outer solar system clean, pulling stray objects into itself or flinging them out into deep space. We have footage of this. In 1994, a comet called Shoemaker-Levy 9 was torn apart by Jupiter's gravity and crashed into the planet. 21 separate impacts, each one larger than the asteroid that ended the age of the dinosaurs. If Jupiter weren't there, that comet hits us. Now here is the impossible part. Jupiter shouldn't be where it is. In thousands of other star systems we've observed, massive planets like Jupiter migrate inward. They drift toward their star, sweeping out everything in their path, including any rocky planets that might have been forming there. We call them hot Jupiters. They're the most common kind of giant planet in the galaxy. Our Jupiter started doing exactly that. And then, something stopped it. Something held it in place at the edge of our solar system, far from us. The leading theory is that Saturn formed at just the right moment, in just the right place, to pull Jupiter back out. Without that dance between Jupiter and Saturn, our gas giant would have rolled through the inner solar system and erased Earth before life ever began. Your species exists because two gas giants didn't collide. But there is one final accident, the biggest one of them all, and it's the brightest object in your sky. We zoom out one more time, to the star at the center of it all. We tend to take the sun for granted. It's just the sun. But the sun is a particular kind of star, a G-type yellow dwarf. And G-type stars make up only about 7% of all the stars in our galaxy. The other 93% can't support a planet like Earth. The most common stars in the universe are red dwarfs. About 75% of all stars are red dwarfs. They're dimmer, smaller, and they burn for trillions of years. Sounds great for life, until you look closer. Red dwarfs throw out violent solar flares so powerful they would strip the atmosphere off any planet close enough to be warm. The planets in their habitable zone, what we call the Goldilocks zone, are also tidally locked. One side faces eternal day, one side eternal night. There is no Earth-like world possible there. At the other extreme, bright, massive stars. They burn hot and fast. They burn out in tens of millions of years. Not enough time for complex life to ever appear. Only G-type stars give you the right balance. Stable, long-lived, bright enough for warmth, calm enough for safety. And our Sun is more stable than even most G-types. Its solar flares are mild. Its output has changed very little over billions of years. We won the stellar lottery twice. Once for being born around a G-type star at all, and again for being born around a particularly well-behaved one. But here's the part that should stop you cold. The Sun won't last forever. It is currently 4.6 billion years old. Halfway through its life, in another billion years, it will be hot enough to boil our oceans away. In 5 billion, it will swell up and swallow the orbit Earth sits on. You're not just living on an impossible planet. You're living during the only window in cosmic time when that planet is habitable. So let's count what we've found. 6 accidents built the world under your feet. Without the moon, your planet wobbles. Climate chaos. No civilization. Without plate tectonics, no atmospheric thermostat, no breathable air. Without a molten core, no magnetic field, no protection from solar wind. Without delivered water, no oceans, no life as we understand it. Without Jupiter, constant bombardment, mass extinctions on a regular cycle. Without our particular sun, no stable habitable zone, no window for life to evolve. Any one of these missing, Earth is barren. All 6 of them on the same planet at the same moment in cosmic time. That is where we live. There is a name for this in modern science. They call it the rare Earth hypothesis. The idea that the conditions allowing complex life are so improbably specific that worlds like ours may be vanishingly rare across the entire universe. Out of the 5,800 exoplanets we have confirmed, we have not found a single twin of Earth. Not one. Not in any star system within our observational reach. We are not just rare. We may be unique, but you don't feel rare. You wake up, you drink coffee, you complain about traffic, you scroll your phone. You forget that the ground you stand on is the result of a 4 billion year cosmic accident that involved a planet-sized collision, a precisely choreographed planetary ballet, a magnetic shield, a star drawn from the rarest 7% of the galaxy, and somehow, exactly enough water arriving from the right asteroids at the right time. You are not lucky to be alive. You are statistically miraculous. This is the reframe scientists rarely say out loud. If everything had to go right for you to be here, and it did, then nothing about you is ordinary. Not your existence, not your thoughts, not the fact that you understood any of this. Earth is not a default. Earth is a one in uncountable. Somewhere in the observable universe, there may be billions of silent worlds, oceans that vanished, atmospheres torn away, civilizations that never had enough time. And somehow, this planet survived long enough for the universe to become conscious of itself. If our planet is impossible, then maybe the right question isn't, is there life out there? Maybe the question is, out of every world in the observable universe, how is it possible that this is the one that woke up to ask? You're not the answer to that question. You're the question itself.